Hello everyone. I welcome everyone here today on behalf of skill-lync. I'll be hosting the session today. We have with us Mr. Ankit, who will be the instructor for the session. So for those of you engaging with skill-lync for the first time, we are an engineering upskilling platform focused on advanced technologies across domains like mechanical, electrical, electronics, computer science, etc. This webinar is part of our outreach with our enterprise business. Our enterprise business focuses on employee training and upskilling across various industries, including automotive, consumer electronics, ITES firms, etc., across various verticals. Today's webinar is on Automotive AI Essentials to bridge the gap between theory and real-world applications. This is the 16th edition of our webinar for corporate professionals. Some pointers. Please post your questions on the chat window at any time during the session. We will share the recording of the video post the session. Please do not ask for the deck, which we will not be able to share the same. So a quick introduction about our instructor. Mr. Ankit Sawa is an AI enthusiast with over 8 years of experience in advanced analytics. He currently serves as the lead data scientist at a leading manufacturing MNC. His expertise lies in leveraging AI and automation to drive innovation and efficiency within the industry. We are excited to host and hear from Mr. Ankit. Over to you.
Thanks, Venkat. I hope I'm audible.
Yeah, you are.
Hello, everyone. Welcome to this session. I'm very excited to, share my knowledge regarding what AI holds for the industry and specifically for the automotive sector. So, in this session today, I'll just start with some introduction. So, as Venkat already mentioned, I'm an AI enthusiast. I've been working in the industry for more than 8 years across different domains, but presently leading a team at a manufacturing MNC here. And today we are going to talk a lot about AI, its application in the automotive industry. I'll try to dump it down as much as possible for the mixed crowd here. A quick overview of the agenda that we are going to cover. We are going to talk about some fundamentals of computer science. We'll try to bridge the gap between theory and application in AI, delve into a little bit of mathematical framework, and explore a little bit advanced programming techniques, and some discuss some ethical considerations in the AI. We'll be able to take questions in the chats and address them towards the end. And please feel free to interact as much as possible. We'll start with a small poll, and this poll will help us gauge the audience today. So please watch out your screen for this poll. We'll bring it up shortly. So this poll basically, will help us to define the audience background today, how much they are familiar with different concepts and what is their primary focus today in the industry. So please make sure that most if you can answer most of them. We'll be keep on asking some or other polls questions in middle to gauge the audience interests and specifically try to answer most of the common questions that's in the industry today. You will receive a poll now. Think there's some problem with the poll. All right, I'll just continue with the content and probably will keep asking questions. So we'll start with a little bit of background, so nothing, we don't need to be afraid of, whatever technical details we are going to talk about. So the two important components of any AI related or programming related field is, understanding the concepts of data structures and algorithms. So algorithms are nothing but they are like step-by-step instruction of execution of a task. You can understand it like type of recipe. Whenever you cook something, you have an instruction on what to do step by step. First chopping the vegetables, then cooking them in some type of oil. So an algorithm is nothing but a step-by-step process of executing a particular task. Data structure is nothing but the objects used in this recipe, like the vegetables, the oil, the gas, right? So they are all different objects part of this recipe, and so they can be considered as data. Now, how to organize that data in a proper, most efficient format is what we call data structures in the industry. Moving on, so we'll be talking about the basics of Python here. Python is the most powerful and the versatile programming language which is widely used today in AI development. Its simplicity and readability makes it both good for beginners and experts, and that's why it's most adopted as well. So there are some benefits and applications both associated with Python, and Python becomes our basis of creating those algorithms that we just spoke about. So some key benefits of Python is, it's an open source language. Open source means it's free to use. And when it's free to use, both users like ourselves, we can use in our projects, and developers can use to develop more advanced libraries for us. It has a large community support since it's all open source. So it has a large community of developers who keep on enhancing, improving, providing documentations, libraries, forums for this particular language. And if some of you must have heard about Stack Overflow. So if you have any problems in any coding related thing, you basically go to Stack Overflow, you type your questions, you get your answers. It's a very big community of Python in Stack Overflow. Similarly, there are a lot of libraries in Python which are continuously improved and developed by this team of developers because since it's an open source. Uh, Also, it's a platform independent language. When you say platform independent, it means you can write the same code across all the different OS, whether it's a Mac, Windows, or a Linux system with just a simple installation of interpreter, and you don't need to change your language platform to platform. Also, it's very easy to write, interpret, and learn, which makes it the most popular language uh, in nowadays. Some top applications that you see for Python is, web scraping, information from the internet, data analysis, computer graphics. Design actually makes use a lot of Python today. Machine learning, big data, Internet of Things, and web development. Uh, Moving on. So let's talk a little bit about what is the relevance of this programming language and into this automotive industry. And whatever we just spoke about, the algorithms and data structure. So let's just start with some examples. All of us, or most of us, must have experienced that there is a pressure monitoring system in vehicles today, which tells you whether your vehicle is low or high on pressure. So if you try to break it down in terms of a mathematical problem or an or a coding problem, right? So there is an associated algorithm which first of defines step by step how it has to be done. So here the algorithm is nothing but the threshold detection, right? So what it does, it identifies the threshold pressure of each tire to basically send out alarms. So that becomes our algorithm. Similarly, data structure is a type of way in which we store this data, which is list or dictionaries. And you can see the one example clearly here. The tire pressures on the front, right and left, and the rear right and left are organized in a particular uh, data structure here. So this becomes an example on how the computer perceives the data. One more example could be windshield wiper control. So if you see, generally in vehicles today, the wipers, they automatically starts when they detect rain, right? So this basically use a sensor-based control. The algorithm is the control itself. The data structure, is the intensity of the rain, right? So once it perceives a certain intensity of the rain, the system starts on its own. Airbag deployment, this is the most common thing, we keep talking nowadays because of the road safety and everything else. So it detects collisions and deploys the airbag to, protect the occupants. So here again, the algorithm becomes the impact sensor-based control, and the data can be as simple as, true or false, whether you are detecting an impact or not detecting an impact. One more feature that it's coming up in cars today is the climate control system. So which basically maintains the desired temperature in the cabin by regulating the heating and the cooling systems in the car. So again, this use a thermostat control basically, and you can set a desired temperature in the car itself, and then according to the thermostat, it senses the temperature inside and controls the system. So these are all very small examples on how real life problems are basically solved, creating some mathematical algorithms in the background. Moving ahead, we'll talk a little bit more about how theory and application can be bridged, the or whatever we just spoke versus what you're going to see in the next slides. Uh, okay, so we'll talk a little bit about AI and machine learning. Very simple, very basic concepts we are going to talk about to understand what it is, what is the hype around of it. So artificial intelligence is nothing but it's a simulation of human intelligence in machines, right? So whatever you do, you think, the actions that you take, how do you make the machine pretend the same and mimic the same is what is artificial intelligence. Machine learning is nothing but a small subset of artificial intelligence, which which helps the system to learn based on some data, right? And it can be programmed using Python. Similarly, deep learning is nothing but again another subset of both artificial intelligence and machine learning, which make the computation of multi-layer neural network. So our brain is full of neurons. It transmits some complex signals, takes some complex decisions. So the entire framework on how the neuron works is mimicked into deep learning. So it's much more advanced techniques. You must have heard about chat GPTs today. So they are nothing but an advanced application of deep learning. And we'll be speaking about it a little bit more in detail in our subsequent slides. So what are the different types of machine learning algorithms that we see commonly today? So again, just reiterating, machine learning is an umbrella of artificial intelligence, and its foundation is based on the disciplines of statistics and computer science. So we just saw how computer science is used to write a particular programming language, define data structures. Now, when we join that particular vertical with stat knowledge of statistics, right, then we basically create nothing but in machine learning algorithms. So it helps in identifying inferences, relationships within the data, and yeah, we write some algorithms to basically enable this. So as you are seeing on the screen here, so machine learning can be divided into three major parts: supervised learning, unsupervised learning, and reinforcement learning. So we are going to focus today more on supervised and unsupervised learning. So supervised learning basically is something where you train the machine in some supervision. So there can be two types of problems in machine learning which can be solved through supervised learning. One is classification problems, one is other is regression problems. So we'll speak about all of them in detail in subsequent slides. And unsupervised learning, two major applications that you see is using clustering techniques, and the other is association techniques. And again, we are going to speak about it in the subsequent sections. So these are the major classes of machine learning algorithm today. Now we'll talk a little bit in detail on what a supervised learning is. So it's a technique where we basically fit a machine learning model with both inputs and outputs of the data known, right? So if you're seeing the example here, the image here, so you can consider this label data as a data set which contains different shapes, right? And this labels as identification of those data, right? Some are rectangles, some are circles, some are triangles, some are hexagon. So this entire data set is a label data where you have all the shapes and you know which shapes are what. So this becomes your basis of training the machine learning algorithm, where you tell, okay, these are the shapes as identified at this particular types of labels. Now, once machine learns this particular pattern based on the labelings that we have provided, right? So whenever it encounters a new data, unknown data, let's say a different shape, then it's able to make predictions and help define what type of shape input shape was. So this is a very basic what a supervised learning means. in machine learning. So there are two types of supervised learning. One is called classification and the other one is called regression. So you can consider classification as, something where you try to make sense of the data at your disposal, right? If you're in a farm, you're trying to identify whether it's a sheep or a goat, right? So whatever data is at disposal, you're trying to make, you know, uh, basically sense out of it, right? So that's called a classification problem. And even the diagram that you're seeing here is an example of classification problem where you're classifying the shapes. Some common examples, if you see, right, traffic sign recognition, where you recognize the stop signs, the speed limits from the images captured by vehicles camera. So it's very popular today in autonomous vehicles. The other one can be the collision avoidance system, where you can potentially detect, other objects on the road, whether it's vehicle, pedestrians, rock, and accordingly adjust your course of action. So it also is a very good example of a classification problem. Other type of problems that you see in supervised learning is solved using regression. So regression, you can assume something like, where uh, you have already trained the machine learning algorithm based on your past experiences. Now you encounter a situation and you try to understand what this situation would lead to, right? So this is just like predicting an outcome based on whatever data you have now. A very simple example could be like, in vehicles today, you see the battery life estimation, right? So not even in not only in electric vehicles, but today this is also available in other vehicles where you see that how much battery is left, how much fuel is left. I mean, the machine predicts on how many kilometers it can run, how much battery is left, right? Based on certain characteristics from the data itself, like, based on your current charge level, based on your driving habits. If you drive too fast, too slow, economically, non-economically, it tells you how much range you can cover. Similarly, based on how your surrounding environment conditions. So, and similarly in vehicle range estimations, your terrains and all of that. So similar things, it helps. So it's helping you predict on how far you can go from your current condition based on whatever previous situations the machine has already seen. So this is a very classic example of a regression type of problem in supervised learning. Moving ahead, the other branch of machine learning, which we will cover, is the unsupervised learning. So unsupervised learning basically, so not every data in this world is labeled. Some data you have to make sense out of it. Right. So unsupervised learning is the case where we've actually fit a model without known outputs. We don't know what the outcomes are. Our goal does not involve to predict any labels here. Rather, we expect our model to enlighten us by finding unseen pattern within the data. So you basically just put the data within the algorithm and let the algorithm make some statistical calculation and draw some insights on its own. So there are different types of clustering algorithms, sorry, super unsupervised machine learning algorithms like clustering, dimensionality reduction, association algorithms. Very good example you can see here on the screen where you have, let's say you have the same example where you had labels, but here you don't have labels. You don't know which shapes are what. And you let the machine define them into three different categories. Now the machine doesn't tell you that these are squares or rectangles or hexagons, but basically categorizes the data into three different levels based on the similarity it has perceived from the input data. So this is called unsupervised learning. It also has a lot of applications in the market, and we'll see some of them today. So we'll talk about an example of the clustering algorithm. So let's say driving behavior analysis, right? So if you want to define or understand the behavior of drivers on a particular road stretch, let's say, right? So you see cameras and other sensors today on the roads. So if somebody wants to understand how the behavior of drivers are on the road, so basically what you do is you segment the drivers into clusters based on their driving behavior, their speed, acceleration, lane changes. These are all driving behaviors, and we identify common driving styles, and based on this, what we do, we take decisions on how to improve the safety of that particular stretch, right? So this is a very classic example of clustering. Uh, Now, the second type of unsupervised learning, which is dimensionality reduction. So this also is a very classic example when you see in a manufacturing space, right? So sometimes you have thousands of sensors mounted on particular machines which collect data every minute, every second, right? And you are trying to understand when a fault is going to occur. So making sense of all those thousand of data points becomes very tedious and may not be very productive. So what do you do is you try to understand which features are important. So extracting basically the most relevant feature from this diagnostic data. And this will help in further downtime reduction and maintenance cost. So you basically feed all this data to the machine and let them tell you which are the important features. So this is again an example of unsupervised learning. The third type of unsupervised learning algorithm is the association algorithms. So again, when you want to, let's say you're a driver, you're driving a car, right? And you let a system give you feedback on what to do next, whether you should increase your speed, decrease your speed, uh, you know, go for a repair. So all this future predictions that or the recommendations that you're getting is based on the driving patterns what your similar drivers are doing, right? Right. So basically, you're trying to identify associations, something like market basket analysis. So you're buying a cake, and with a cake you also buy a spoon, right? How this is possible? Because you see a lot of data where people are buying cakes with spoons. So you're trying to make identify patterns, buying patterns. Similarly, here you're trying to identify driving patterns based on what people are doing generally, right? Whether and then you give them specific feedback, recommendations, and maintenance alerts. So these are all very good examples of unsupervised learning. So far we have covered supervised learning, classification and regression, unsupervised learning, where we are talking about clustering, dimensionality reduction, association algorithms. Supervised learning, we talked about labeled data, and unsupervised learning, we are talking about unlabeled data. So now we are going to talk a little bit more about the mathematical framework of AI automation. So basically, this entire writing or creating machine learning algorithms makes use of statistics, data, and algorithms, right? So algorithms now whatever data you are using to write an algorithm basically makes use of a mathematical framework, right? On how basically you want to crunch the numbers to get a specific result out of it. So this is what we are going to talk now. So little overview about what data science is, and then probably we'll talk a little bit about mathematics. So data science is a field of study that combines both domain expertise and programming skills and knowledge of maths and statistics to extract meaningful information. So one has to have all three knowledge to basically solve a particular problem using some AI methods, right? Nowadays, organizations are moving from intuition-based decision making to data-driven decision making, and that is why this becomes very important. We'll talk a little bit about some mathematical concepts in very higher level. So two very important things that we see that we make use on in background of machine learning algorithms is vectors and matrices. So vectors are nothing but one-dimensional representation of data. If you are looking at this image here, so this is a one-dimensional representation of data. Two-dimensional representation of data is called matrix, and n-dimensional data representation of data is called tensors. And I'll show you how this becomes important in classifying and creating some machine learning problems. So you look on the right side, this black chart here, right? So this is a particular problem that I'm trying to show you. So let's say we have a data set which has different heights of different people recorded, their ages and their weights. And let's say the second column, we want to predict, how, what is their, let's say, uh, their possibility of having a particular disease, right? So your machine has to learn this data first. Now, how do you give your machine this data? So you give it in forms of this type of data structure, the vectors and matrices. So if you look at this first row of data has height of 170, age of 24, and the weight of 70. So you define it in terms of vectors, and this vectors then finally is consumed by machine learning algorithm. Each row is converted into vectors and finally into metrics, and then you can define a mathematical problem. You just like linear graph, right? Where y-axis is height, x-axis is age, and you're trying to predict the weight, sorry. So similarly, the data structure uses some mathematical concepts to be transformed into a certain shape or format, which can be consumed by this machine learning algorithms. And that this becomes our basis of our statistical problem solving as well. I'll take a pause for, for 5 seconds for you to have a look at it. Moving ahead. So we'll talk a little bit about the key statistical concepts, right? Since we spoke that statistics is one very important pillar which combines computer science knowledge and domain knowledge to give you some meaningful insights out of data. So statistics play a crucial role in AI. It is a discipline that concerns the collection, organization, analysis, interpretation, and presentation of the data. So there are two major statistics techniques that we use in machine learning. One is descriptive and the another one is inferential. So the descriptive statistics basically covers two things, two sections. One is the measure of central tendency and the other is measure of dispersion. So if you have a data set, let's say you have data of hundreds of people taking a test, right? So you want to understand how their behavior is. So in terms of data, then you use descriptive statistics to define, right, what is the mean score, the median score, how many of them have got highest score, the lowest score, how many people have got the top 10% marks, top 15, bottom 50 marks. So all of this comes become part of the descriptive statistics. Inferential statistics you makes use of some advanced statistical tests to uh, basically define whatever uh, insights you draw from a descriptive statistics, whether it holds true to the entire population. So what it means, I'll go in detail into next subsequent slides, but for now, this is what statistics would mean for us, descriptive and inferential. So talking a little bit more about descriptive statistics, which is basically measure of central tendency, as we spoke earlier. So let's just again assume this particular distribution that you're seeing here is, let's say, of few students who have taken a particular exam, and their x-axis is the scores of their exams, right? So this can be, the graph can be, when you draw it, it can be either of three, right? Whether it's a right skewed, left skewed, or centered graph, right? So, the measure of center tendency basically use a single value to describe this distribution, right? So very simple example, we'll understand what this measures of central tendency is. We'll talk about average, right? First. So suppose there are 12 numbers you have, right? How do you identify an average? So average is nothing but, summation of all of them divided by the total numbers you have. So here the average of all these numbers is nothing but 7, right? Similarly, we'll talk a little bit about what is median. So median is the most middle number. So if you have, let's say, 15 numbers, so if in this example, right, you have this numbers here. If you arrange them in ascending order, excuse me, then the median is the most middle value. And we'll talk about what significance it has in statistics, but this is the median value, right? Similarly, if you talk about mode, so mode is the most appearing value in particular data set. So here, if you would see in this particular data set here, 9 is the most appearing value. So 9 become the mode, right? So this all three of them has different statistical significance. And if you look on the graph, you can see mean, median, mode plotted here. And for a symmetrical graph where the distribution is symmetrical, the data distribution, you would see all three of them basically overlapping each other. Okay, so we'll talk a little bit about now the measure of spread. We spoke about the measure of central tendency. We are now going to talk about the measure of spread. So measure of spread is nothing but it talks about how the data is spread, like whether a lot of people have got similar type of scores or these scores are spread across. So this measure of spread is basically in statistical term called standard deviation. So it basically refers to the amount of dispersion of a data point from the central value, which is the mean, median, or mode. In other words, we are trying to calculate how spread out our data is. So, for example, one way of understanding how the data is spread to understand minimum and the maximum value. So, let's say the minimum score is 0 and the maximum score is 100. So, we know the data that the students have got variety of scores, and not just everybody is, and not that everybody is limited between certain scores only. So, here in this example, if you see, one is the lowest and 13th is the highest. Similarly, the standard deviation or variance, basically, variance and standard deviation are two related terms. So it tells you how much your data varies from the central number, from the mean of the number, right? So, for example, if you see there are different animals here. So the mean value is the 394 of their height, and all the different animals are of different height. So how far they are from the mean or the average of the entire population is the understanding of variance. So if it's too far from the mean, then you would see this distribution. And if it's very close to the mean, you will see this distribution. So this is what is called, so the statistical way of measuring this graph is the standard deviation and the limits, minimum and maximum. So far you must have got an idea on if you have a particular graph, let's say this one, then how to how to define it in mathematical terms. You can use the measure of central tendency to define where the peak lies. If it's a right skewed, then the peak will, sorry, the different points will lie in different areas. And the other would be to identify how spread out it is by using statistical methods of variance and the range. Now, the second branch of statistics, which is the inferential statistics, right? So far, we spoke about descriptive statistics, which basically helps you describe your data, how your data looks in terms of mathematical values. Now, once you know what is the maths behind it, now the second task is to make inferences out of it. On what do you mean? If a mean score of class is 10, it means no, not most of the students have performed well, right? But is that statement true or not? Right? Suppose you have a class of, let's say, 100 students. You have taken sample of only 10 students, and you know that this 10 students have scored on an average only 10 marks out of 100. So does that mean the entire population of 100 student has also scored so badly? So how to make that assumption is what we learn in inferential statistics, right? How to make use of that sample data to make prediction for the entire population is what is called the inferential statistics. Because in real world, if you see, right, you won't get all the data, right? So suppose I have a machine which is running for a certain duration in the shop floor. So you might collect data for only 1 or 2 hours, but would want to understand its behavior for the entire day. Then how do you make that inference using is made possible using some statistical inferential statistical methods. So it's a while the descriptive statistics summarizes the data you have, inferential statistics use the summary to make predictions and generalizations. So it makes use of probability theory, hypothesis testing, proper sampling techniques to uncover the hidden truths and make some informed decision. As you see, right? So this is the population. We do some sampling and we collect data for only few people out of it. We do some descriptive statistics on top of this population, and then we make some recommendations for the bigger population based on the inferential statistical methods. So this is what we do in statistics today, right? We'll talk about an example. Let's say you are a manager at a large corporation, right? And you want to understand how a recent change in your company's work from home policy has affected the employees' productivity, whether they are able to execute more tasks or less tasks, right? So it's So there are two things involved, right? So first we will define the descriptive statistics, then we'll talk about the inferential statistics to derive data recommendations, right? So in descriptive statistics, as you understand, first we collect the samples, then using those samples, we make some summaries, data summary using descriptive statistics, and we use those summaries to make inference for the larger population. So let's say we collected data for only 200 employees who are working from home. Right. And we also have historical data of employees who are working from office. Let's say we were able to summarize the data. We know that the work from home, mean task that people were completing were 25 tasks a week, let's say. And from work from home and one from office setup, people were completing only 22 tasks. Now, by just looking at this, it's very evident, like to make a conclusion that, okay, that people are more efficient when working from home because they are now executing more tasks. But it's not so simple, right? We have only collected data for 200 employees, right? There will be thousands of employees in in that company. So how do we use statistical methods to determine whether the inferences drawn for a sample is also true for a particular population, is what we cover in inferential statistics. So first step is hypothesis testing. So these are some statistical tests: t-test, ANOVA, and then there are other statistical tests also. So I'm not going to talk in details, but I'll just use some terminologies. Let's say we have conducted a t-test. We compare the mean 25 of in work from and work from home policy to the population mean of 22 in the work from office policy, right? Uh, the hypothesis testing basically we do is we define two types of hypothesis, well, a null hypothesis and a alternate hypothesis. A null hypothesis is nothing but we make a statement, let's say work from home policy has no effect in the productivity, and the alternate hypothesis becomes work from home policy has increased productivity. Let's say we did the hypothesis testing and we got a statistical value which we call a p-value, which is less than 5% probability. So it means that we reject the null hypothesis. And when we reject the null hypothesis, so we draw this conclusion that the work from office policy likely increases the productivity across the entire workforce. Though you might not follow the entire statistical method used here, but this gives you an idea on how hypothesis testing or a inferential statistic method can help you to basically do some calculations and define whether the results that you're seeing for a sample also holds true or false for the entire population. Moving ahead, we'll talk a little bit about the advanced programming techniques for automotive AI. Uh, So we'll talk a little bit about deep learning. So far we spoke about AI, machine learning. We'll go a little bit into introductions of deep learning. So as I mentioned, deep learning is nothing but it's basically mimicking the mechanism of the neural networks, which is basically our brain itself, the network of brain itself. So how our brain is basically defined, right? So it basically processes complex decision making using the complex data that we collect through our different sensors in our body. It can be either object detection, speech recognition, language translation. So these are some common use cases that we see in day-to-day world using some deep learning techniques. So in artificial neural network input, so this, if you see this diagram below, it's a diagram of our neuron in our brain, right? So we'll try to understand from here. So if you see the input nodes here, which are the dendrites, so they receive signals. The hidden layer here basically, which is the nucleus itself. So it processes the input signals, and after processing the input signals, it sends out the output signals, but this output signals are produced based on some activations, right? So activation can be, right, if let's say somebody is pinching you, so your brain is able to perceive that somebody is pinching you, but you don't react until the pinch is hard enough, right? So that strength of pinch is the activation function, right, on how hard you're pinching. So that defines your activation. So similarly, if you see in the same neural network ML algorithm, so you have different input nodes, and you have a you have a place where it processes all this information using some linear function, and then it has an activation function which basically defines whether the output of this linear function should be released or not. And this is how the deep learning methods work. So there are also ways of making it more intelligent, which is called back propagation method, and our brain also use that back propagation method. So back propagation method is basically once you have taken an action based on some inputs, right? Now basically you try to identify whether the output was something expected or not. If the output you find is not in line with your expectations, then your neurons learn again. Your neural network learns again, adjusts its input signals, and gives you an output again, which is in line with your expectations. So basically, it's a self-learning mechanism. It keeps on learning from its trial and failure to understand how to readjust, and that's how exactly how brains are doing, right? When we keep on doing certain activity, we know what is the right way of doing it because we keep on readjusting our neurons. Now we'll talk a little bit about TensorFlow and PyTorch. So these are some very popular open source frameworks in building AI models specifically for the deep learning models, right? So they basically offers tools and libraries for creating neural networks. It's not a programming language, it's a framework that we use basically to create deep learning models. So TensorFlow was the library first created by Google, and since then it has been open source. Similarly, PyTorch is for Facebook's AI research lab library, and it's a open source as well, right? So these are two different products out there, frameworks out there in the market, popularly used. Both have their advantages and disadvantages, but we are just going to limit our scope to understanding them. So they play a very crucial role in developing and optimizing algorithms for perception, decision making, controls in autonomous vehicles because they are all very complex tasks. And some tasks they are basically we do via this type of framework is using object detection, path planning, and we are going to talk about some of them in our subsequent slides from here. Um, Now we are going to deep dive a little bit more on how an autonomous driving vehicle or technique works. Having understood everything from the basics of statistics, mathematics, programming language, data structures, what is vector and matrices, and what are the different types of AI techniques. So we are in a position to understand how an autonomous driving vehicle basically works. So you must be seeing this screen on the screen, this diagram here. So it's a depiction of a vehicle with different sensors mounted on it. So the laser sensors, the GPS, the video cameras, the radar, ultrasonic sensors. So these are different sensors which are mounted on an autonomous vehicles to basically collect different types of data from its environment surrounding and the vehicles. Now, based on the different types of data it has received, uh, it basically processes all those data and basically makes some sense out of it, which is the next decision making. So it's basically a complex sensing system to evaluate the external environment and make some actionable decision for safe navigation. Just as people use senses like sight, sound, taste, smell, and touch to understand the world around them, autonomous vehicle do the same through sensor fusion. And we are going to talk about sensor fusion. Sensor fusion is nothing but processing all this data from all the sensors together. Autonomous vehicles have five core components, which helps to optimize operation in real time because it has to take a decision real time, right? It cannot wait. So one is computer vision, where it basically senses data through cameras. Sensor fusion, where it makes sense of every data coming from every other sensor. Localization, where it tries to use GPS sensors to understand its current state or current location. Then the path planning. So based on whatever data you have so far collect using GPS and cameras and lidar and other sensors, so now you will use your navigational sensors to do some path planning and optimization. And finally the controls. So now all these actions, four actions, will result into what decision you want the vehicle to make, right? So that is the control system. So these are the five most important component of a autonomous vehicle. Now, autonomous vehicles can also learn about traits exhibited by the drivers like driving speed, car temperature, driving mood, traffic signs, regular songs that you play, favorite radio stations that you play. And by rating driving skills, these autonomous vehicles have helped to change bad driving behaviors and habits, right? So it's not just stops at taking the decision on what to do next, but it also helps to improve the road safety, driving behavior, and everything else from whatever past learnings it had with different drivers and their patterns. So we'll talk a little bit about the sensor fusion that we spoke in the previous slide. So sensor fusion is nothing but, making sense out of all the sensors data that is being collected by all the sensors. So there are primarily, multiple types of sensors in the vehicle as we saw in the last chart. So this sensors allows us to understand the world and process information to go from one place to another safely. The most common types of sensors that the automakers that mount today on vehicles are lidar, radar, camera, and ultrasonic sensors. So lidar, which is a light detection and ranging sensor, basically it continually measures range and scans its surroundings for obstacles. So it basically provides a 3D mapping of street, buildings, car, and the pedestrians walking on it. The other type of sensor is the radar sensor. So the radar sensor basically it emits, so it's just like a whale, communication of a whale and sonar we must have learned in our basic physics and maths. So radar sensors basically emit electromagnetic waves to gather more information about an object's velocity, range, angles through the speeds of the reflected waves. The camera are another type of sensors which capture images, videos from different angles to obtain a visual data of things that can only be seen, like traffic signals, animals, road markings. These are also very important. And the ultrasonic sensors basically they emit pulses of sound to detect large and solid objects nearby through speed of echoes, right? And they're used to measure objects that are in proximity, such as, while parking the vehicles, it's very important to understand if something is around you, right? So we make use of the sensors also. I'll show you how this different sensors working together helps an autonomous vehicle to make some sense. So these are the important terminologies that you must have already heard in some or other driving sessions that you might have had. So adaptive cruise control, emergency braking assist, pedestrian detection, collision avoidance system, lane departure warning, traffic signal, sign recognition, surround view camera, cross traffic alert, blind spot monitoring, right? Rear collision warning, and intelligent parking assist, right? So all these different colors that you see marked here are different radar sensors that we spoke about and how they are working together to help you make decisions. So for example, this one, the long range sensors, if you see here the red one, so it helps you in adaptive cruise controls because it helps you adjust your speed based on what's it detecting ahead of you, right? Similarly, emergency braking, if you see here the orange lights here, it makes use of the lidar technique. Surround view camera, basically, all the yellow ones that you see here are the camera sensors making decisions. So they're recognizing lane departure warning, traffic signals, looking at your surroundings around you, both front and rear and sidewise. And similarly, there are some other medium range sensors which helps you to monitor some blind spots. So these are the spots which are not visible to a car driver, right? It helps to measure that, avoid collision, and things like that. Similarly, ultrasonic sensors, if you see here, right? So these are all used during the parkings when you reverse the vehicle and park it, right? So you would want to understand, how other vehicles or objects are placed around you. So this is how all the sensors working together helps a vehicle to, develop its own senses and artificial sense of surroundings around it. Moving ahead, one example I wanted to share. So since we have spoken a lot about autonomous vehicles, how different sensors are working together, so I'll just show you one scenario on decision making of this algorithm. So if you see your first step, if you remember, is the data collection, right? So here, suppose in this autonomous vehicle, there are two types of sensors installed. One is the camera, and the other is the lidar. So this two sensors basically they continuously capture the visual and the depth information about your surrounding. So let's say this is the depth signature from your surrounding, and this is the visual image of the road ahead of you. And it also know the navigational commands based on, let's say, Google Maps or something, on which direction you have to take. So now it has three types of data. One is the depth of the road, visual image of the road, and the navigational command. Now this three commands collected basically goes into your neural network. So this neural network basically deciphers the data by doing a semantic segmentation, right? So it segments the data to identify, basically it processes the data, right? So the sensor data are collected, and this is the neural network basically processes the input to understand the uh, what are the different signals and the depth and the visual image and the object detection happening. It takes and it defines necessary control actions, like whether you need to change your this navigation, steer left, right, or slow, or take a sharp right or a sharp left. It also helps to tell you whether you should brake or accelerate more, because these are the final controls, right? So this is how the neural network uses your input data and take some intelligent decisions on the direction and the speed. So scene understanding, the semantic layer created by neural network, basically it helps you identify whether what you're seeing through camera, right? Whether it's a road, it's an obstacle, or something else. Based on that, it takes decisions. But let's say you see let's say you see a animal here in the road, so it would tell you to steer little right, brake, and then steer left once you have braked. So these all decisions are taken here. Now, after the control actions are defined by neural networks, so there are, control action generations. So it generates certain actions now. So, so that you can navigate easily and safely and efficiently. So this is done through PID controllers. So PID controllers that refines this high level instructions received from neural network into specific commands for the vehicle steering and the throttle system. So now the vehicle actuators basically, after receiving the PID control actions, so basically it decides on braking, accelerating, and steering, and executes command that the neural network wants it to do. So this is how an entire cycle of autonomous vehicle works based on the application of deep learning. I'll take a pause for you to have a just look at this diagram for once. Moving ahead. Uh, Now that we have spoken so much about different techniques used in AI today, so there are obviously has to be both positives and negatives with the application of AI, right? So there has to be some ethical considerations associated with it, so that we make basically just use of the technology at our disposal and we don't misuse it. So everybody has to take care of this today. So the ethical standards basically with the rise of AI, right? So there are different significant advancement and same time challenges that it poses, right? So this ethical standard ensures responsible development and deployment of AI technologies. Now, AI ethics is a set of principles guiding the responsible use of AI, right? So we have to have some guidelines. It is relevant because it has high impact decisions, with decision that basically has high impact on our human lives and society, and it also helps us to develop our trust and reliability on some such autonomous systems. Now, key ethical considerations are safety, privacy, and accountability. So we'll talk about those in our next subsequent slides. So we'll talk about safety first, safety considerations. Again, human life is a priority. So ensuring AI systems prioritize human safety is above everything else. Robustness and reliability. So we have to test our system again and again so that we know it is so it's it's robust, and we also have to implement multiple backups at multiple point of time so we know it's reliable, right? And some regulation and standards are some the different industries have different types of compliance and standards defined. So one AI systems has to basically comply with all those standards and adhere to the government safety regulations. Privacy considerations, one very important talk of the town is, data privacy. So type of data could include personal data, data from sensors, from machines. So data collection has to be transparent, right? So users should know what type of data is being collected, how it is being processed. Data protection is the next item. So removing personal information from the data is very important. No, you won't like your personal data to be processed at all. Similarly, it has to be securely transferred as well. You won't want it to be exposed to other. User consent is also important. Users should have an consent on whether they would want their data to be controlled or not. And this should be clearly defined, and this policies should be clearly accessible to everyone to read through. Now, some accountability considerations for companies, corporates, individuals making such AI system is, first is the clear responsibility definitions. We have to define roles for manufacturer, developers, and users because they are all the stakeholders while making this AI systems. Legal liabilities has to be defined. We have to determine how, in cases of accidents and failures, who is liable, what are the remedies available to them. Ethical decision making. So transparency and algorithms, like basically a user should be able to access all those documentation which defines how an AI algorithm is working. It cannot be a black box, right? Then only it helps in more scrutiny and improvement from there. And it has to mitigate bias, so it has to be fair and it has to be safe. Governance is again very important item here. So we have to establish committees to oversee AI ethical concerns. Regular reviews of AI system is important for ethical compliance. And in situations of incidents, right? So we have to develop clear protocols on how to handle them and implement certain feedback loops to learn from such incidents and improve on our systems. So this all becomes very important while one learns about AI systems, start developing it, or start being part of certain developments, right? So responsibility becomes very important in certain scenarios. With all of this, I would like to take a pause, and this is the end of the session for today. We'll like to take some questions from the chat and would conclude it from here. Stop sharing. Over to you, Venkat.
Thank you. That was a great session. Folks, the chat window is open. I will shortly open up the mic access as well. Please feel free to interact with our guest speaker today. The mic access is available in case if you want to directly interact with Mr. Ankit, it's possible for the next few minutes. Ankit, would you like to talk to them about the next webinar we have planned? Folks, we have shared the feedback form here. Basis your feedback, we are open to arranging the next session with Mr. Ankit on a little bit more advanced topics. Ankit?
Sorry, I was on mute.
Um,
So
so,
yes, please go ahead.
Sorry. Yeah, Ankit, I just wanted to have a quick question on the neural network that you have mentioned. So,
Mhm.
in the vehicle where these components would be integrated, is that part of an ECU or is that a something separate control module which has all these AI-related components?
So they all say nowadays there is a standard modules that and frameworks that is basically used to integrate all the systems, and that they are definitely separate from the existing ECOs. So that it becomes universal basically, so that one module can be applied across different vehicles. So we just keep it separate. Does that answer your question?
Oh yeah, sure. Thanks. So, are these connected through CAN as we normally do for other modules?
I'm sorry, can you please come again?
Uh, are these different modules connected via CAN or something like that? Or
Actually, I'm not too much aware about that. I'm sorry for it. But as I understand, these modules are different from the existing modules, and how the integration happens, I'm not exactly aware. As you know, I'm more of a technical expert than a shop floor engineer. Sorry
okay,
about that.
okay. No worries, no worries. Thank you.
So CAN is a communication protocol existing between various hardware components as well. I think there's a little bit of misunderstanding. They just want to know how the data is recorded and processed and how it
Oh,
is communicated to the system,
okay.
automotive system.
So there are two ways in this data is actually stored and processed. So one is using the cloud computing today, right? So most of these vehicles are connected to the cloud systems, right? So most of the sensors, they send this data to some or others. Let's say Tesla has its own cloud servers, right? So this data is sent out to their servers, and the servers store and processes this data, and in backend it runs the algorithms. The other is where these algorithms are directly deployed on the vehicle itself, which we call as edge devices, right? So what happens, all this data is locally processed into smaller data units in the system itself, and the decision making is controlled in the machine itself. So for example, there may be certain situations where you lose connectivity, right? Where you're in certain remote areas, so you would not want to rely on cloud, right? So we have both type of techniques available depending on the manufacturer and the budget and other considerations.
Okay, yeah, that makes more clear. And one last question. So, how for a newly produced vehicle which doesn't have any kind of data available, where the customer hasn't used, how would be the the calculations are done based on any general data?
Yeah, so you got the last part correct. So what happens, we generally manufacturers do a lot of testings right before launching certain products to the market. It requires a lot of beta testing where they basically give it out to distributors and other partners to collect more data. But that might not be enough, right? So that's where they use some generalized data collected, through research or market surveys, and try to make some decision making. And that's why autonomous vehicles are not, very readily available, you would see here, right? Because it requires a lot of learning, and that learning will only come from testing, because each vehicle, each make might be different from another manufacturers and the way it behaves. So for example, lane detection and others could depend directly on the cameras, right? So if a good camera and a lidar sensors, right, so it can definitely make some decisions based on some defined rules. But based on the safety ratings of your vehicle, based on how your steering capacities and capabilities are, so this needs to be further customized when you do a lot of beta testing.
Okay, okay, understood. Thank you for that.
No problem. So I see
There is
it.
a question.
Yeah,
I'm
yeah.
sorry,
There's
Ankit. There is a question in the chat window from Tanuja. What's typical real time taken for decision making and processor used?
See, when you're driving a vehicle, you would want to receive signals within milliseconds, right? Because you would not want to wait for a decision to be made when it's too late, right? So generally, it's typically within seconds and milliseconds, and that's why the system has to be very robust.
Thanks, Mr. Ankit. We can go ahead and talk about the upcoming webinar plan.
Okay,
Folks,
yeah.
meanwhile, yeah, sorry, go ahead.
No problem. So I think the upcoming webinar, we are going to talk a little bit more in detail about, the advanced AI techniques that we touched upon today. We are going to talk about data management, some practical applications of machine learning. We are also going to talk a little bit in depth about the deep learning techniques that we saw today, right? And then we are also going to cover certain, you know, in-depth understanding of certain systems. Let's say in the autonomous system, you must have seen that it takes decisions based on certain perceptions. So how those decision making is done, all that, we are going to cover along with the ethical implications of AI. So basically, it's going to be a little bit more advanced than what we saw today. Uh,
Thank you, Ankit. So I've floated the feedback form in the chat window. Please take your time to fill it up. Meanwhile, we have Ankit for the next 10 minutes. If you have any questions, please take this opportunity to interact with them. Usual question we get is like for somebody who is interested in who's from the automotive field, who has some basis in data science but wants to get into automotive AI, what would be the right way to go about it?
Yeah. So one of the slides I have tried presenting on how there has to be three components which has to play a major role in your data science journey. One is the domain knowledge, the other one is the statistical learning, and the third one is the knowledge of programming languages, right? So if you have any of the two, you have to master yourself in the third one, right? So if you're specifically targeting a particular field to enter, then probably you will have to develop a little bit of domain knowledge into that field on, what is happening, what is trending, what type of algorithms are being used, and how they are working today. Right. So I think understanding of all three is important. For understanding of statistics and machine learning, I think there are a lot of online resources available today which can be accessed, and within few months, one can basically understand the basic components, but the major learning again comes with practical application, which is an on-job learning.
Thank you, Mr. Ankit. We are not seeing any more questions. Folks, we'll keep the window open for next 2 minutes. If there are no questions, we'll go ahead and close the session. Kindly ask you to fill the feedback form. We have also posted our LinkedIn page. Follow us for more automotive related news and insights. Vasavi, are you speaking? You are not audible.
Yes. Ankit, very good afternoon. I am Ratnakar, working as a principal of an engineering college.
Okay, yes,
Can
sir.
you give me a few suggestions or guidelines wherein I can drive my students towards a better career in automotive industry, especially in autonomous vehicles, because this is buzzing now. I think they can
Yeah.
get more opportunity. Can you give me a few clues, or can you give me a step-by-step some directions for me as an administrator, so that I can guide my teachers as well as students in the direction, so that employability can be enhanced? Thank you.
Thank you for asking this question, because this is something which is missing in academia today, right? So most of these students that I've seen, even myself, we learn when we are outside the college. But I think the first application has to come from experience, right? So we have to start introducing certain types of lab exercises. Like, for example, we know that there are a lot of like electrical and mechanical labs which has a lot of instruments where we go and do certain experiments. So how do we integrate this data collection and data analysis behavior in that lab type of situation itself will first help students to grow more interest into data analysis, and also basic learning of Python. So as I mentioned, Python is a language which is easy to learn, easy to understand, and easy to execute. So it doesn't require any special skill sets, and also free to use, right? So it is no harm if we start including learning of Python and its implementation in data analytics with our co-curriculum activities. So I think these two things should be prioritized and will help. And then there are other things like participations into different types of forums, right? So there are a lot of competitions that keeps on going on in the market. There are certain platforms where you can, like, let's say Kaggle. So Kaggle is one very good platform where you see a lot of competitions going on, where people come and they work with certain types of data sets, and they post their answers. So if we encourage a competitive behavior, right, organizing hackathons in-house or encouraging students to participate in certain types of competitions, then that will also involve, help in generating more interest among the students. So I think it should start with practical application and learning of theory first.
Thank you, Ankit, for your insights. But I have another small doubt, if you time permits.
Yes, please.
What is you said na integration of different sensors within this module, and does it has something to do with IoT?
It definitely has to do with IoT, because IoT is nothing but, like, sensorization of everything in a shop floor or a factory, right? So today, when we are working in industry, right? So we see there are a lot of PhD students which are coming from across the globe. The only reason, and most of them are Indians, right? So we see only reason why they stand out among others are because they have lot of exposure to the practical way of learning, right? So for example, we have seen they know how a particular sensor works, how to integrate that system sensor in an existing system, and how to collect data, and how to make some analysis out of it using some edge devices. Right. So let's say you have a vibration sensor, you have a motor which is running, right? So how do you mount that vibration sensors near the shaft, so that you can effectively collect data using some edge devices? So I think that also becomes an important part, right? On not just on data collection, but understanding how our data can be collected using certain devices. So I think that is important as well.
Thank you, Ankit. Thank you very much.
Thank you, Mr. Vasari. Anybody else? Any other questions?
This is Venugopal. Just I have one question. Can
Yes,
you
please.
listen me?
Yeah.
Yeah. Tell me about how you compare with the statistical methods with automotive. Like you explain the statistical curves, no? Like
Yes.
how it is get connected with the automotive systems.
Okay. So I'll give you a very
AI or machine learning
yeah.
methods.
So all these AI algorithms, right? So I did not get into any specific one, right? So there are different types of AI algorithms today, right? So it's called linear regression, random forest, bagging boosting. So there are a lot of AI algorithms. So this AI algorithm, the basis of it is how you use statistics to combine with the learnability of the machine in an effective way, right? So all of this use different statistical methods, right? Of crunching the data, crunching the number, making inferences, so that, and then it uses some mathematical way of optimizations in these algorithms to reach a particular output. So all the neural networks that you have seen, right, and the autonomous vehicles that I explained. So these are different. So it's not just one program. There are different programs which works. So these different programs use different mathematical concepts or statistical concepts to optimize or get a result. So for example, let's say an image classification, right? Your sensor camera captured an image. Now the neural network uses a specific image recognition algorithm. So basically recognize that image and then classify it into certain type of classes. So this image recognition algorithm basically uses statistics in background and mathematics in background to basically understand the patterns and make some recommendations. So that is how it is integrated in a broader way. I hope I answered your question.
Right. I think there are no more questions. Ankit will go ahead and close the session. Thanks once again for joining us. It was very insightful. I found it as a marketing person, even I found it very useful. Thank you so much. Look forward to more such sessions. And thank you all participants. Yeah.
Thank you. Thanks all for joining. Have a nice day ahead. Bye bye.